Good afternoon. I'm Alex Russell. I'm a software engineer on the Chrome team at Google. And I'm going to leave some time for questions at the end today. But I joined the Chrome team not because I care necessarily about Chrome as a browser, although I do at some level now. I'm sort of tied to this massive C++ hairball that is a browser. But my primary interests come from spending life in the trenches as a web developer. And I realize now that that explanation of why I continue to work on this particular set of very hard problems is wearing thin. It's been a while, I guess, since I was an honest-to-goodness web developer. But I spent a lot of time building JavaScript frameworks and tools for people who had real problems building real UIs. I mean, the sorts of things that that were required of you when you were trying to do business intelligence dashboarding across very large data sets on IE6 were unmentionable. So I'm not going to mention them. But needless to say, this scarred me for life, and now this is my cross to bear. And so I'm one of Google's representatives to ECMAScript TC39, or ECMA TC39, the standards body for JavaScript. And so I could talk to you at some length about what's coming in JavaScript.next, but there are other people here, thankfully, who have already taken up that cause. So I won't bore you, because their talk will be more entertaining, not that it's boring. But I do spend some of my time these days on the W3C technical architecture group trying to make sure that we can improve the batting average for people who are trying to design web standards, in part because when people design web APIs today, they tend not to design web APIs, right? Think about the set of people who are building APIs for us. Generally speaking, they're C++ hackers. And I like to say that you don't sort of get to the end of the boss fight as a web developer and get handed a C++ compiler and a source checkout for Chromium, right? That's not what happens. You get to the end of the boss fight as a web developer and you've made beautiful products for end users, right? You've made great things for end users. Like, there's just no sort of clear trajectory from one to the other. You could do what I did and move from one to the other, but it's, again, sort of the cultural fluency between these two groups isn't very high. So there is a group. You wouldn't believe it by the state of W3C specs, but there is a group whose job it is, or has been, to try to assert some amount of quality control over the specs and APIs that come out of it so that things look and feel good and are relatively idiomatic with regards to JavaScript and all the rest. It's been something of a slog. We're working on it. Give us time. But we wrote this thing. It's called the Extensible Web Manifesto, and it tries to embody a few properties of what I happen to think of, and the team that I've been working on with web components and some of the other technologies that you've heard of maybe this week, about what it means to build web APIs well. So if a developer comes to you as a browser guy or browser person and says to you, hey, I really need this feature, you have a couple of options. The first option, and the one that most frequently gets exercised, is to tell people to piss off. The second option, if you are in a less capricious mood, is to tell people that they can have that feature, they just have to tightly describe to everybody what exactly it is they meant. Now, the best case scenario for this conversation, if it starts off that way, is for that person to go back and do a ton of homework about what it is exactly they meant. Because the odds are pretty high that they didn't actually know all of the finicky details of what it was that they were trying to ask for. And they certainly don't understand the constraints necessarily that you have as a browser vendor, right? Why can't I just have X, right? Where X is my parochial problem right now is a very common question. And it's a very good question. Why can't you have it, right? You should be able to have nice things. This is 2014. What the hell are we doing here? So the other way that this conversation could go, instead of that person coming back with a very specific description of their very specific problem and their very specific design constraints for their application, is that the person who works in a browser could go, OK, great. Let me make you the lowest level API I can think of to get away with that'll give you the power that you need to go do this. Now, that seems, on the one hand, a little bit crazy and a little bit difficult, because how do you identify what that lowest level thing is, right? JavaScript doesn't have a memory model. We're not going to go sit there and talk about how you move dwords in memory in order to get access to the camera API. That's not sort of what we're going to do. So there is like some level of abstraction that you sort of have to reckon with between, a VM's internal implementation strategy and what it means to have a very high level system like HTML. And so you have to figure out where in there you can sort of get to a low-ish level, right, in order to satisfy this request. And this is a better way forward, we think, because it embodies a little bit of humility about not knowing what you don't know. We have a lot of experience with designing web APIs, and I'm going to talk about some of them in a second. I'm going to try not to beat them into death, because we were ignorant in some cases. We designed a lot of web APIs where we didn't actually know what we didn't know, and so we answered the specific problem that was directly in front of us, and we gave people a specific answer for their specific problem. And then as soon as they got stuck, they were completely screwed, because there wasn't a script API, or the script API didn't explain the entire feature. It only exposed some piece of very large, like one lever to control a very large machine, right? It's like giving, a cockpit with only a single joystick in it. No rudder, no ailerons, no ability to control the thrust. You just have a joystick, right? This might be the idealized interface for flying an airplane, but it mostly requires telepathy. And when it doesn't work, you're probably going to crash. And that is the experience of web development today. So we'd like to do better, and designing lowish level features is how. So I like to think of the other major challenge that we've got as people who are building web apps as trying to be first class, right? We try to be part of, we carried along with the software and OS ecosystems that we participate in, not as some sort of, little sidelight or some other bit of third-party content, but as something that these OSs actually have to care about, something that's actually bought into the UI, that users expect from the stuff they interact with. And that's a very fluid definition, and it's definitely set by the OSs themselves. It's set at the level of them setting up a bunch of user interface expectations and then having users swim in those expectations for as long as they can stand it, right? So what do we need to get there? I submit that we need, at least in the current situation for web development, we need offline that actually works. Like, we need to be able to make things that are reliable and trustable, and as trustworthy to interact with as a user as touching an application. Now, the good news for us, and this is a little bit of a sleight of hand, is that most of the apps on my phone, the native apps on my phone, are pretty balls when there's no network. They just suck. And they tend to suck because they have the expectation that they're going to be online. But the OS has pulled a very clever trick in that it has put it in the developer's court to figure out what to do offline. They're going to launch your application, but then it's up to the application once it's launched to do something about offline. So users tend to blame applications when they don't work well offline. They don't tend to blame the ecosystem or the entire application platform. Whereas on the web, you spend a lot of time staring at a blank white screen, don't you? Because we don't have any expectation that things are going to work well offline. So we need to figure out a way that we're going to flip that expectation. Next, we need access to system capabilities. You kind of all know what I'm getting at there. And we need integration with system UI. And this is a tougher ask, and there's obviously no clear one way to do it. We've tried a lot of different methods between Firefox OS and Chrome OS and Web OS and a bunch of the other OSs that we've tried to take web technology and package up in some different way to get access to those system bits of UI. But they haven't really panned out, because now you've just lost everything that's great about building on the web. You're not hosting your stuff at a URL. You can't do easy A/B testing. You can't push quickly. You have to build something basically twice. And HTML, JavaScript, and CSS are not the best part of anyone's day. Let's be honest, right? Like, they're just not the joyful experience of building something for the web. The reason you build something for the web is that it has this really powerful set of capabilities that you can deploy frictionlessly to your users. And that's the capability we want to preserve. Web deployment, not necessarily HTML, JavaScript, and CSS. So we really want the ability to have a flow where we can add something and be part of the top-level UI in the OSs that we've got. We've got sort of a dummy version of this now with add bookmark to home screen in both Safari and in Chrome. And then we want to be able to launch from that and actually show up in the top level and be able to be seen in the task switcher or show up in the launcher for whatever OS that happens to be, right? Being part of these top-level OS affordances as ourselves and not as a piece of content that's in the browser, right? Pulling the content out of the browser, escaping the tab ghetto. That's where I think we all want to be, or at least that's where I want to be. And it's where I want the applications that I interact with most frequently to be. I want to be able to alt-tab to Gmail as a top-level thing, not to Chrome. I want to be able to alt-tab to Facebook as a top-level thing, not to Chrome, right? I love Chrome. Chrome is great, but like, get out of my way. I want to get to my stuff. The OS already gave me ways to navigate this stuff. Help me do it. So let's talk about offline that works. I spend a lot of time on airplanes. It's unfortunate. It happens. And I get this a lot. A quick story. I was living in London for about a year and a half recently. And Before the 2012 Olympics, the brilliant mayor of London, Boris Johnson, decided that a first-class city needed first-class infrastructure. So what he was going to do was outfit all of the tube stations with Wi-Fi. And you heard that correctly, the tube stations with Wi-Fi. So it's possible today to have, and they were free during the Olympics, so you could get on a tube stop somewhere in central London and take yourself out to Heathrow to get on one of these airplanes where you were seeing a little dinosaur, and have roughly the same experience, but much more frustratingly, because you would associate while you're standing there waiting for your train, and you would start loading a news article or something. You'd get on the train, because there's one every 2 to 5 minutes. That's brilliant. Public transit that works. And you'd find yourself whisked away to the very next station about 2 minutes later, just before TCP timeout hit. So you'd be sitting there waiting for the rest of this article to load, and the browser wouldn't have figured out that you weren't online. Except you were kind of online, and it would try to associate while you're pulled into, Shepherd's Bush and Covent Garden, and like on and on and on and on. You can pretty much do this dance all the way to Heathrow and never actually get that article. It's possible. So I think of the old world as actually being a little bit better, right? You kind of knew when you were online. This was a piece of equipment that you drove. You actually sort of put yourself in the driver's seat and you sat down and you decided that you were going to take control of the computer and sort of put yourself in the driver's cockpit and press the modem button and yell to everybody in the house not to pick up the phone because you were on AOL. And so we all had this experience of sort of like being in the online mode, which was not the norm, but we sort of knew that we were. But today we're occasionally connected, and being occasionally connected is perhaps the worst kind of offline, because you think you might be, but you're not quite sure. And the only way to test is to go out to the network. And so now we've got a situation where these things that we're carrying around with us embody the worst case scenario for the web's model, which was very much designed around the notion of this thing all the time. But now that expectation is fundamentally broken. Every link looks like it should go to a wonderful new world of content, a wonderful new ability to see something, when instead you often wind up just at a white screen, and that's bad. So we have a low trust issue with our users. And so we need to get to a place where we can deliver experiences offline that just sort of always work. And even when we're quote-unquote online, it's really bad. This is a slide from Ilya Grigorik from Velocity Conference last year in New York. And he gave an entire talk, I recommend you find it on YouTube, about getting pixels on glass in the critical 1 second boundary. Like after about a second, between a second and 10 seconds, users they've noticed they're out of their flow, they're annoyed. Whatever they were going to your thing to do, they've now come out of that process and are thinking about doing something else, because it's not very good to sit there for more than a second. On the desktop, we sort of have done better than this in the best case scenarios, but on mobile, that entire second can be eaten up by 3G and 4G physical layer startup. This is really bad. This is really, really, really bad. It's never mind the fact that the MLC flash devices that you're hanging around with in your pocket are slow and getting slower. Never mind that they've got low internal parallelism and that the file systems don't tend to work really well for the devices that they're on, just sort of acceptably well, or that when they fill up, they get slow. Forget all of that. This network is worse. This network is always going to be worse. In the desktop world, this was going on a reasonable DSL connection, 10 to 12 hops out of a backbone. This was going to Australia and back several times from here, right? This is bad. So we need a way to defeat this. And this is what native apps do. They don't necessarily load faster. They don't necessarily actually put pixels on screen faster from the point where they can get content in. But there's something there, and they can load directly off the disk. So let's do it. Let's get ourselves to a place where we can do this. But to do this, we need to understand that applications are shells plus content. So what's a shell? So let's think about a blog. Today, the way we construct our applications is that you take for some silly, agency creative thing. They've got a blog, right? And maybe it's a series of static files on disk someplace. Well, if they've got a blog, then they've sort of thought about the navigational aspects of this blog. They've got like the link to home, our team, our story. It would probably be like products, solutions, services, things that don't actually mean anything. But instead, there's a bit of sort of discernible content in the bloggy blog 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 bit, right? Like that's actually different content, and you wouldn't expect that to be repeated from page to page. But everything else in this document is actually mostly navigational. It's stuff that you might expect to see repeated. And you sort of see this with native applications or with applications you're used to on the desktop, where there's a bunch of content that you're actually interacting with, and then there's the shell around that content. We have spent a lot of time coming to terms with how to build that shell on demand every single time you load an application. Now, some applications do a little bit better than a bunch of files on disk. And even a blog can be significantly more sophisticated than this, right? What are all of the URLs that you would imagine are going to be generated out of this WordPress database schema, right? I don't know. I couldn't tell you, right? So again, we've got this bit of discernible content that's separate from the Chrome around our UI. And so we can think about them independently. And we've got some of the technology to do it. XHR, Ajax, page transitions. We've got good routing frameworks now. We've built ourselves a very tall tech stack that makes this possible. And in fact, our best applications, the ones that are sort of aspirational, do this already. They think about a shell of stuff, and then you've got little bits of content inside. You see this all over again, right? There's the shell that gets me around my stuff, and then there's the stuff that I'm actually playing. So now imagine that we go back to that question of how do you build a feature. This is Jake Archibald's design or description for how app cache actually works. Let's go back to this moment where a web developer said to a browser guy, person, something, dog, and said to a browser dog, hey, browser dog, erf. I need to be able to get a thing while I'm offline, and I want you to give it to me. So what they did is they came up with a list, a way for you to list out the set of things that you were going to need when you're offline. And then it figured out how, under certain circumstances and in some places, it might decide to give it to you. This is the kindest description of app cache I can possibly come up with, and I won't dwell on it more. Needless to say, the decision tree gets quite complicated because the set of things that your application might want to do are also quite complicated. And that's nobody's fault. That's just life, right? You're trying to deliver an application experience. You're not trying to deliver a series of bits of static content, right? We've mapped some static content onto URLs. That's sort of an artifact of, the way a regular web server directory setup might work. But that's not sort of how real apps are built. You start thinking about delivering different stuff there. Okay, so we need to start thinking about offline as bootstrapping the shell of our application and then loading some content and then synchronizing changes. This is a major architectural change for those of us who aren't already using some of the really tall frameworks, the Embers of the world, or those sorts of things, which already have synchronization potentially built in. I think that the synchronization framework thing is going to be actually the next big framework war, because very few. I mean, I know that Meteor has good OT support for local data model synchronization with the server side. And then there are other folks who are working sort of in the OT and CRDT style of synchronization technologies. But most JavaScript web app frameworks, like if you're just building a straight down the line backbone thing, you've got no support for this, right? You have to think about your data model and how it changes to it locally relate to changes to the server remotely. Will relate to each other over time on your own. There's no sort of built-in batteries included for that. So this is the challenge I think that we're going to have when we start to move to a world where the technology below us lets us do offline well. Okay, so service workers are a new feature that we are adding to the web platform, and specifically my team is helping to add them to Chrome. And they are an in-browser proxy for handling fetches. They are an in-browser proxy that let you run a little bit of JavaScript to do whatever it is that you damn well please whenever a fetch event happens from a document that you happen to control. And when I say you happen to control, I mean is part of an origin that you registered the service worker from. Okay, so service workers are installed on the very first visit to a web page, or whenever that you happen to run code to install them. But that means that the very first load of a web page can't be controlled by a service worker. It's a background thing that gets installed later. It gets installed asynchronously, and it gives you programmatic control over requests, responses, and a new cache storage type. And that new cache storage type deals in requests and responses. It's a cache of responses keyed by requests is the easiest way to think about it. And you can communicate to controlled or tabs that you happen to have been loaded through the service worker using post message and message ports if you so choose, in addition to obviously sending an XHR out to your origin, which the service worker might see. It also has a built-in mechanism for managing upgrades to the service worker and its dependencies itself. It's a quite complicated dance, but the easiest way to think about it is that it works the way Chrome's update system does. And again, this isn't brilliant. This is us just stealing the best ideas we could find. When Chrome shuts down, and it's auto-updated in the background, it's downloaded some new stuff in the background, and you relaunch it. Firefox works this way now too. When you download it, it downloads its new version in the background, and when you kill it and you bring it back up, maybe say when you restart your computer, the new version launches instead of the old one. This is the way service workers version themselves by default. You can keep pushing new versions of your site and your service worker in the background, and they will be downloaded for you, assuming the user is visiting your site frequently. And when the user closes all the tabs to your site and comes back, the new version will be used instead of the old one. And you'll get a chance to do some cleanup work from the old version if you like. So conceptually, a page is loaded or a navigation request is made. Again, this is one of Jake's diagrams to explain to the world how this works. A page is loaded or a request is sent, and it goes to the service worker, and that can go to the network. But the service worker also has access to this cache API, so it can request some content out of the cache. And it can use either the network response or a cache response, or make one up and send that back to the browser to handle the contents of that page or any of the sub-resources of that page. Cool? Again, it's an in-browser programmable proxy for your app. Nice. So how does it work? So to register a service worker, this is from a document, right? So inside of a document, let's say I'm going to look for the service worker thing to make sure that I'm not calling this in places where it won't work. And then I'm going to call service worker.register. And there's an optional property bag that you can pass as a second parameter, but we don't really care about that. This is going to register a service worker for the entire origin. It returns a promise, so that .then there handles that. And then you'll get a handle back to a registration object. And that registration object will let you know things like the scope, which in this case is going to be /, and the state of the service worker itself. Because installation is asynchronous and happens in the background, you might care to listen for whether or not it's going to be updated or how it's progressing through its installation phases. And so you can provide UI to users about how that's working. Cool. Again, installation is asynchronous and in the background, and I can't stress this enough. If you decide that you're going to build an application that puts up a loading bar while you wait for the service worker to install, I will come find you. I mean, in the nicest possible way. I'm not actually. Who does that? So you got to serve something to the user on the first request, right? Don't be that person. Don't be that person who puts up the progress bar. And you can think of service workers as progressive enhancement at the network layer. They can fundamentally change the economics of your application's network interactions because you can cache large amounts of stuff in the background. And you can do that process of downloading stuff opportunistically in the background and potentially allow yourself to remove some of the pressure from that question of, well, I've got this first load latency. I need to get something down the pipe. But now I've got this worry about making sure that I've got assets that are actually rich enough, and my frameworks want to do more, but I can't afford it because I need to get assets down the pipe quickly. It starts maybe presenting a way for us to sort of progressively enhance our applications with more functionality if they're loaded through a service worker, if the service worker is there and available to handle responses, maybe serving fatter versions of our frameworks or more capable stuff. So how do we, again from the document context, how do we talk to the service worker? So note that we get that promise back from navigator.serviceworker.register, which tells us basically when it was downloaded and that registration object will let us know when it was downloaded and when it evaluated correctly, right? So there's a bunch of phases in the install process after that. So we can talk about them in a minute. But the navigator.serviceworker.ready lets you know when there's an active service worker, which is to say when you sort of would have expected the next page load to consult the service worker before doing anything else. Cool? All right, cool. So it's worth thinking that now that we've got a handle to this thing, this active service worker, we can post message to it. But there may have actually been a moment between these two things when the service worker was killed. Service workers are entirely event-driven. They live and die based on the scope of the events that you send to them, either by navigating to them or posting messages to them or some of the other events that we'll see in a minute. But that means that you can't count on global state inside the service worker to keep your application ready. So you need to synchronize stuff if you're doing work in the service worker. And it'll get an on-message event when I send it a post message, and that might have revived it from the dead. There's a one-to-many relationship between service workers and documents. So if I go to acme.com/index and acme.com/foo.html in a different tab, there will be one service worker, logically speaking, that's serving both documents. And so it can see both documents in a list of its clients in the API. So the question of install is like, when does install finish is important, because it's important for you to think about your application as not just being a single resource or maybe a single list of resources, but maybe as the stuff for the UI and then maybe a bit of actual content. And you can think of those as being separate caches. Like, we conceptually sort of think of that as being separate caches. In app cache, you would have had to deal with that separation using IndexedDB to put your logical content, and then maybe app cache to handle your shell. But that's really unnatural. A lot of these things are HTTP resources anyway. So the service worker lets you build caches, and this e.waitUntil, this event.waitUntil, lets you say, I'm not done installing until this thing succeeds. You pass it back a promise, and if that promise fulfills correctly, then now you can control when the browser thinks installation is done. And the service worker won't be active for new documents that get navigated to until this process finishes. So that gives you some control over the installation process. Caches are asynchronous too, and they're keyed by request, not URL. They're a flat namespace, shared origin-wide, so name them carefully. But that's just because they're like every other storage thing, like IndexedDB and local storage, where every document in the origin can see everything else in the origin. And you can cache cross-origin resources too. This is really nice. You may not be able to see the contents of those resources if they weren't sent with CORS headers. But let's just say I wanted to get, imager/cat GIF, right, and put it in my thing and show it offline. This is a really nice lightweight composition system that we have on the web today. And service workers enable that. They let you cache third-party resources, but they don't give you access to the content. So you'll get an instance of opaque response instead of the normal response object. And they are subject to quota API limits. We're thinking hard now about what this means, because service workers might grow, and we're going to be watching carefully to see what people do with service workers to understand how this might affect the quota API. OK, so all right, we got our service worker set up. We've registered it. I'm going to the very next page, right? Like, I've gone to acme.com.index.html, and I click a link to something else on acme.com. Inside my service worker, I'm going to get a fetch event. And it looks very much like a regular DOM event. And I can handle it that way. It's got properties, the request, the URL of the request, the method, the headers. I can see all this stuff about the request that's coming in, and I can choose what to do with it. I can say e.event.respondWith and send some promise back to do some work. Now, the lifetime of my event will be however long it takes to resolve this promise, which means that the service worker won't get shut down until I've successfully or incorrectly resolved my promise. If you pass back an error to your promise, you'll get a network error from the document's perspective. Cool? All right. So let's do something interesting here. We can create a little pass-through proxy. There's a new API called Fetch, which we've made available inside of service workers. You can think of it as like the XHR you've always wanted but never had. And it just takes a request and potentially a bag of other options. But you pass it a request, and it will go to the network and hand you back a response object, which is the sort of bread and butter of the service worker, the request and response objects. And you can respond with the promise that Fetch hands you for a response object. And now you've got a simple, really lightweight, transparent proxy. And you can do things like logging there, right? Or transparent caching. You can even make up your own responses. So in this case, you can use the response constructor and pass in a bag of stuff and handle it. So if you wanted to do client-side templating, for instance, you can do that. You could even do the templating once, store it in a cache, and have the disk system handle how to respond with it. So let's look at how we get something back out of a cache. So we can call respondWith, and we can pass it a match for a cache thing. And then because the response might not actually be there, it's not an error necessarily to not get a response from the cache. That's not an exception. If we don't get it, we can go to the network for it. Does that make sense? So we can use promise chaining to make sure that this thing is always responsive. It's never blocking, and that means that we can continue to handle new network requests that come in behind this request from the service worker, very much in the same style that Node uses to keep things responsive and handle many concurrent requests. OK, read-through caching is also really simple. Like, what if we wanted to go put some stuff into the cache when we don't already have it? I know this is a little bit of a promise triangle or a little bit of a, you know, a leaning tower of promises. But you can think about this as like if-else's. And I won't explain it all here, but you can do it, and it fits on a slide. Isn't that cool? So if you get some requests in, and you don't already have it, you can go to the network for it, put it in the cache, and then respond with it immediately. So that you can build a little transparently caching proxy on the client side. So what does this do for our little 100 millisecond budget to get nice things in front of the nice people that we wanted to serve? Well, we're removing potentially all of that control plane startup for the physical layer. We're removing all the DNS RTT time for a response that we serve out of the service worker. We're removing all the TCP setup, and we're removing the TLS handshake too. So that's pretty good. That's pretty nice, especially over a slowish connection. On a mobile connection, we're removing the HTTP request response overhead, which is maybe another 100 milliseconds. On desktop, it'll be about 5 times faster than this, maybe. We can look at almost a 600 millisecond savings for second visits to service worker sites on 4G, 3G, and 4G. Right? This actually lets you reliably put pixels in front of users while you're cogitating about what you're actually going to show them. Maybe you have something cached. Maybe you want to go to the network to try to figure out if you actually have a network connection that you can go request new content with. Or the best apps that I use on my mobile devices kind of know what to do. They show me what they've got, and then they go to the network to get new stuff. So you got to serve the shell locally, and that means you need to start warming up required connections from inside that first request that you get. And then we want to render and then update. So we need to make sure that we get something in front of the user which is intelligent enough to tell the user the status of what's going on, show it a little progress bar, or tell it how fresh the content it's looking at is, and then give the user something to do about whether or not they're online or offline. But I hate to, bring this up. The service workers are secure origin only. This means that you can't use them unless you've got TLS deployed on your website, and they won't work for the HTTP content on your website. This is a really good thing because it's a very powerful feature, and having service workers available to HTTP might mean that, like, let's say you're in an internet cafe, or worse, on crappy hotel Wi-Fi where they've put one of these, like, big splash screens in front of you to get you to sign in. The last thing you want is some malicious or incompetent third-party actor getting between you and your stuff, and maybe serving you a service worker script, right? That would be very bad if it's persistent and lives a long time. So, secure origins only. Go put SSL on your website. It is harder than it should be, but it's not slow anymore. So please, it's 2014. Edward Snowden happened. Let's do it. So I was at Velocity a couple of weeks ago in New York, and Steve Souders had been bugging me for a long time to sort of talk about the service worker and these numbers and stuff. And I just stole all of those numbers from Ilya anyway, so I don't know why he needed me. But I popped into the Google office the next day to do a little bit of work, and I thought, I can totally make my flight. I've absolutely got this. This is a straightforward thing to do. I'm going to leave at 1 o'clock, and that'll get me there in time for my like 4:30 flight. Perfect. 1 o'clock stretched on to 1:20 to 1:30. I was having a really good conversation. I needed to talk to some of the folks I work with on the ECMAScript standard, and then before I know it, it's 1:45. I run my butt downstairs to the chutes and ladders that are the Google New York office. If you've ever been, I recommend a map. And I need to get myself to JFK as fast as I possibly can. So I put myself in the middle of absolutely the worst traffic I've ever seen in my life. But it wasn't even in one of the sort of iconic taxis. It was in one of these things, which looks like someone had like grabbed a toy Prius from the back and stretched the back of it. And it's even better because they've built these new taxis in such a way, if you get in a London taxi, it's clear that they've sort of like smushed everything to the outside so that there's room for you. Here, despite stretching it upwards, they seem to have kept the, I suppose it's iconic New York taxi feel by saying, what if we took a minivan but like removed all the legroom by putting this really tall thing in front of you? So they've kept some aspects of it. So I'm sitting in one of these things, and I'm watching my time tick by, and I'm never going to get through security in time. This is just not going to happen. And my pre-check, okay, I'm texting my wife. I'm not going to make it back. This is bad news. And at some point in here, I realize that I've got the United app installed, and so I start looking at it to see if it's been delayed. Maybe it's been delayed, right? Maybe. I heard something about weather. Okay. And I look at it, and it didn't send me a notification. I don't know what I did wrong there, but it didn't. But I looked at it, and eventually it told me that my flight was delayed. This is amazing. This is the best news that I've had all day. But I don't understand why I had to go to the United app when there's a very fine, well, okay, not very fine. There is a United website that has many powerful features that this application does not have. And this website has many terrible UI features that this application does not have. There's just a lack of parity is what I'm trying to say. And so it would be really great if these two things could sort of get together, and this one could show me something about my flight status. Oh, I seem to have put this in the wrong place. OK. So let's talk about what it would have been if there was a better website for this. Right? I've gone to the United website on my phone, and I know that I've done the dance where like Chrome synchronized my passwords, and I've logged in, and all that stuff. And it knows who I am. Wouldn't it be great if the website could just give me a notification that my flight was late? That'd be better. So we're bringing this to Chrome. We're bringing push notifications and messaging, push messaging and notifications to Chrome early next year sometime. I can't give you an exact date because, this is how standards go, but we're working on this very hard. But basically, the way this works is that it all integrates with service workers. So if you've got an SSL website, which you probably do, or should, you will soon, right? Yes? Once you have an SSL website, you can install a service worker, but then we can think of push messages as just sort of being another event that comes into the service worker, like on fetch or on activate or on install. We can imagine that a push message just wakes the service worker back up, because remember, we can kill it any time, wakes the service worker back up, delivers the message, and potentially goes back to sleep. That's pretty great. But from there, we need to be able to tell the user that something just happened. So we've added notifications. So this is how you register for a push. And this is the W3C spec that we're iterating on in public with Mozilla and folks from AT&T and other places. But you say navigator.push.register, and you pass in a sender ID. And then once that potentially succeeds, maybe it asks the user whether or not you should be allowed to do pushes instead with an info bar or something, as it will in Chrome. You'll get a push registration ID back from the object that represents that registration. So then you can send that registration ID back to the server so that it can do things like individually identify you as a client and then send you push messages later. I don't have the intestinal fortitude to attempt a live demo of this today. We tried it for I/O, and I, nearly lost the contents of my bladder. Needless to say, this is going to wake up the service worker even if it's not running, even if Chrome is closed, even if your application has totally gone away. This will allow you to send messages to users with a native notification the way you kind of expected it to work all the time, right? Isn't that what you want? Like if they're wearing a device that pushes notifications to their wrist or something, you should be able to get the notification there too. You should be able to dismiss it in one place, have it all go away. Deep system integration with the host OS is an incredibly desirable property, and it's something that we have been a little bit remiss in delivering to you as developers over the last couple of years. We're trying to redress that balance. But to get there, you need to get a service worker on your site. OK. So from inside of the service worker, you just add another event listener the way you always would. You'll get some data back in, because the push server can potentially send you some data. So you can decide what to do with it. In this case, I might think of it as a JSON package, because I know that that's what my server is going to send me, and decode it. There are length limits, and those are specific to your push servers, and you should think hard about that, and you should architect your application in a way that is resilient to that. But, c'est la vie. So let's say I'm inside my service worker. And I get one of these messages, right? And I've got a title to it. I want to show the user that I just got some stuff. I can create a notification, and I can, send it a resource that I've cached locally potentially for an icon, and give it a message body, and potentially give it a much richer set of detailed information about the rest of the push contents. But the service worker true flag here on the new notification constructor says when you get interactions with this notification, send them back to the service worker. Like, let's say the user has closed Chrome, or they've closed the browser that you're using. It'd be great if the notification that was there didn't go away too. You might have actually wanted to tell the user something quite important that they don't want to miss. Closing the application shouldn't necessarily disqualify you from having a persistent notification someplace. But when you get this back, you potentially have lost a lot of context. So what happens here is you'll have the notification click and notification close events, and they'll tell you something by giving you an opaque ID that you can use to join things up with the previous notification. You can even do things like, if I had a notification earlier and someone clicked on it, I can decide to close it. All right. So where are we with this implementation? I want to leave a little bit of time for questions. We're designing all this stuff collaboratively in the open, mostly on GitHub, but it's all going through standards, at differing rates. Service Worker is the furthest along. In the inside baseball parlance of the Chrome and Blink projects, we've sent an intent to ship message to a mailing list. I know, a message to a mailing list, earth-shattering. But it basically means that we think we've got an implementation that's far enough along that people might want to use it, and we're hoping to get it out to you by the end of the year, worst case scenario, early next year. There's a first public working draft at the W3C. We're going to be doing another working draft hopefully soon. We're implementing right now. Google is quite far along, and Chrome is going to be shipping some stuff. There's other stuff that we'd like to add into all of this. Obviously, getting response back from the network is good, but getting it as a stream is potentially even better, giving you even better control over your latency and potentially memory usage for very large objects like videos and that kind of thing. Why shouldn't you be able to have a streaming music service in a web browser, right? And we've designed the entire thing to be extensible. Notifications and push messaging are the two first APIs to come down the pike, which add new events to the service worker and extra API alongside. And we're hoping to make it quite easy for other APIs to integrate in the same way. Background synchronization and alarms are an obvious next step that people have been asking for. Geofencing is something that people really, really want. And Bluetooth Low Energy access to other devices is something that we are looking at but have no ETA on. We also want to ensure that when you cache stuff in these caches, that if you run afoul of the Quota API, you have a chance to do something about it, and potentially give you more room by default. Well, we're going to figure that out. All right. So I know that's a lot, and I know that some of it's a little bit inside baseball, but I'm happy to answer any questions that you've got. Yeah.
All right. So the push notifications and such, is that going to function on mobile devices as well?
So the question is, push notification is going to function on mobile devices? And the answer is that it's coming to Chrome for Android first. Probably early next year. Very early, I hope. But yes, we're going to be shipping it on Chrome for Android and then moving it to desktop as soon as we can. And that will, again, go out with Chrome, which auto-updates on Android and is in most places already. Other questions? Yeah.
You mentioned a lot about integration with so, for example, handling push notifications from integrating with Apple notifications. That's defined by coding the browser. Is that something? Where is that?
So the question, I think, is related to what should we do on iOS? Yeah. So so the Android version and the Chrome version for desktop are powered by GCM, which is the Google Cloud Messaging System. But the API that we just looked at is not specific to those. And in fact, we're very hopeful that other browser vendors will implement this. We know that Mozilla is looking at this. And they're going to have their own messaging backend. So what we're not doing here is standardizing the entire pipe for how messaging works. We're standardizing the API that your browser knows how to talk to. And at the IETF, we're standardizing some of the backhaul stuff, because today there's a really crazy situation where you have to go know who you're talking to and then speak a particular message format to their server to actually deliver the pushes. And it'd be nicer if that was better. But in general, other browsers that decide to implement this stuff should be able to execute the same code and deliver notifications in whatever is the right way to do it. And it'll be up to browsers to integrate well with the OS. So for instance, there is potentially a path for us to do this on Chrome for iOS or Chrome for OS 10. On OS 10, we can use GCM, but on iOS, we're going to have to think hard. That's not scheduled right now. That work is not scheduled, but it is something we're thinking about.
Can you swap to the latest, the last slide with the near term? Yeah, one back.
Oh,
yeah.
Sure. Yes.
And you mentioned that has there been talk about rather than synchronizing, rather than pushing data to the browser, pushing data to the OS. Like I'm thinking there are websites that already try to push to notification center on the Mac.
Yeah, so the notification systems that are going to actually do the underlying delivery of these messages are usually integrated with the OS. So for instance, on Android, we're going to be using the OS integrated Google Cloud Messaging service, not something that's specific to, was your question from a server pushing to some other bit of UI?
No, in terms of whether the service were to push notification, can it be configured to push directly to an OS notification center, like in OS?
That's what happens here. The notifications that you create actually show up in the integrated into, for instance, the Android notification list. They are native notifications. Yeah, no, we're not doing this halfway. Yeah.
How do you feel about polyfilling strategies that sort of bring out parts of this functionality to the market faster? Good thing, bad thing?
So polyfills in general are great. Polyfills are a difficult question when you're talking about fundamentally new capabilities. So prior to work on service workers and these new APIs, I worked on web components, and part of our strategy there was to polyfill aggressively. So there's a library called Polymer, which has a whole team spun up, and they maintain not just a library of controls for the Polymer UI framework, but also polyfills to enable those controls in browsers that don't work. I think it is it's a great thing to do when you can. It sort of is a good way to help bridge the gaps that we've got in uptake rates for browsers. I'm hopeful that the mobile web is going to continue to improve faster than the desktop web did at roughly the same age in its life cycle. But yes, polyfilling is generally good when you can.
As to this functionality,
Service workers can't easily be polyfilled because they control at the network level. So you have to have something to run the code to do the polyfill. And because this is, the way to think about this is that there is, let me switch back a little bit. There isn't anything else that runs code between a page and the network, right? You have to have something to intercept that first navigation. When I go to a page, I need to have something there, right? So for instance, I'm gonna attempt a live demo of one of Jake's things. This is a site called an app called Train to Thrill. Obviously, it's built in Chrome, and it goes to the network and it gives you, you know, sites off of Flickr or photos off of Flickr of trains from around the world, right? And it's built using service workers. And I'm going to take this network cable out. And I don't have, yeah, no network up here. I got no network, right? It's running a local server, and I'm going to kill that. Let's go kill that. I've killed that. And now I'm going to refresh the page. Still there, right? And it's going to tell me that there's no connectivity, right? There's nothing else in the browser that can do this. There's no other place where I could have responded with some content and then run a document to tell you, oh gosh, I can't get to the stuff that I really wanted to now. So this is a fundamental new capability, and those are a tougher thing to polyfill because you sort of need the hooks. This comes back to the extensible web stuff because what we have failed to do in the past as people who are building browser features is to give you those hooks, right? You may have noticed that all of these APIs that we're showing you are exactly that. They're APIs. They're not declarative high-level markup features. We tried that with App Cache, and we tried that with Google Gears, and it didn't work. And the reason that it didn't work was because we thought we knew best, or we thought we understood the entire problem. And it's generally not the case that we understand the entire problem. And so the only way that we can actually redress the balance here is to give you these hooks. And so this is one of these new hooks. Yeah.
How's the disabling of the notifications going to work? Is it going to be at a page level or browser level?
So was the question about disabling notifications? So how does disabling notifications work? We are looking hard at how to manage or provide control surface area in a more general way to users. Unlike native applications on some OSs, notifications are permission that you request. Persistent notifications are permission that you request, and you'll get an info bar. The user can say yes or no. We're adding a little gear icon. I don't have a mock here, and I'm sorry for that. But we're adding a little gear icon to the notification itself to let users get back to that management surface area, and that'll land in Chrome 40 and 41. And that surface area will let users disable notifications on a site-by-site basis. And that's something that we're hoping to enable universally everywhere that we have this API, so that users are actually in control and like they can with a lot of the other permissions that we expose on the web, audit and then exercise some real authority over what the application can do on their behalf.
That can be a bit cumbersome because you have 10 websites and you don't want to be notified by all of them.
That's right. Yeah, we're evolving out of the tab, right? And as we do that, we have to provide a lot of the affordances that you'd expect an OS to naturally provide. And sometimes they don't, which is really annoying. Yes?
How does versioning work?
How does versioning work? Versioning is somewhat complicated. So I'll try to describe it quickly. I mentioned earlier that there's a model wherein a new version of the service worker itself might be requested in the background, and its install method run. And once that install method successfully completes, it will be the service worker in waiting, which is to say, when you close all the tabs that you may have been looking at that would have been entwined with the previous version of the service worker, when you visit that site again, the new version will get activated and the old version will get deleted. And so that's the general model. There's a wrinkle in that model, which is that a new service worker can choose, if it wants to take control immediately. It can say, no, I'm ready, I'm done, give it to me right now. And that's a conversation. We thought hard about that API, but it's a conversation that really only a new version can have with regards to an old version. Old versions aren't generally competent to reason about the next version of their application. But when do those get fetched is an important question. The service worker script and its resources, which are pulled in via import scripts, are fetched. Let's say I go to google.com every day and it has a service worker. We will obey HTTP expiry about that service worker script up to a 24-hour limit, at which point, even if you specified a far future expires header, we're going to ignore it and go to the network to see if there's a new version of it. If we detect that there's a new version that's even byte for byte different, we'll treat that as a new one, download it, try to download its resources, try to run its on-install event. And if that succeeds, it'll be the new one in waiting, right? Does that make sense? Yeah. So users visiting your site is generally what's going to trigger the update process.
Are service workers still identified by URL? And if they are, what happens if you try to install two?
Are service workers identified by URL? Service workers are differentiated by scope, which I didn't show here, but it's think about like /foo and /bar or /calendar and /mail. Those can be two separate applications with different service workers. They have to be careful not to step on each other's toes with regards to naming their caches and that sort of thing. And hosting multiple service workers on a single origin is generally an advanced feature. Don't recommend you try it. The flexibility is there in case you get yourself into hot water, but if you can at all help it, the only secure thing to do is to model different applications as different origins or sub-origins.
Just one more question. Is there a possibility to find out if there are already any workers installed and kill it?
Yes. The question is it possible to know if there are already service workers installed and potentially kill them or uninstall them? Kill them. They're not persistently running. They probably aren't alive when you encounter them.
Kill them as in...
Unregister them?
If you try to navigate one more time, the worker will not install.
Yes. It's possible to unregister a service worker, both from inside the service worker itself and from a document that loads. But the service worker sort of gets first crack at loading those documents. What is possible in the update process is for you to serve a new version of the service worker that's an empty script. And service worker requests for service worker scripts and their dependencies are identified with a service worker /script header, which you can look at on the server. So let's say that you wanted to disable all service workers across all of your sites. Put a little something in your htaccess or httpd.conf to look for that header and deny requests to those origins, and that'll work out. Or sorry, those resources. Yeah.
How about content security? Say, for example, that you have that as part of your application you have a restricted directory. Can you identify, for example, resources on a service worker that even though they're part of the application, should not be downloaded?
Service workers have control over that process. Service workers can control who gets to download what, but again, if you should not be making security decisions about the content of your application on the client side.
Okay.
Yeah. Because this is client-side code, the user can inspect it and modify it. Yes?
Does an end user have to access the service worker?
Service worker installation is silent. So
Because like, if I go to a website and the website starts downloading a lot of graphs,
there's the quota. Yeah, that's right. So the question is, how can you prevent sites from downloading lots of stuff? Well, the answer is that we have a quota API, and the quota limit right now is quite low. And eventually, things that aren't used will get flushed. But service workers are likely going to be a little bit more persistent than other sorts of caches. That's actually a debate that we're having right now, is how to treat them with regards to cache eviction. There may be a separate permission that we add to opt a site out of cache eviction when the user clears their caches, and that would be a separate info bar, info bubble permission that the user grants. Cool. I think I'm way out of time. So thank you so much. I'll take questions in the hall, but thanks for coming and thanks for your attention.